So for understanding the difference between simple moving average and exponential moving average, let's say I put the data for 12 months. I first take the sales data. Let's say this is, I just taken random data, okay? Now, if we want to do a simple moving average based on quarters, quarter means average of every 3 months, we can do that. So if you go to data and go to data analysis pack and take the moving average. So the moving average input range will be your sales. Labels are not there, so I will exclude it. Or rather, we can take the labels also, but then take the entire thing. Interval, we are keeping 3 months because we want to do a quarterly forecast. And output range, we can probably put it here. And we'll also take the chart output. So this is your simple moving average. Okay. You can test actually. So if you take the first 3 months ka average, the forecast for the next month is 26.67, right? ये देखो इधर 27, 32, and 21 were the actual sales for the first 3 months. So the average of that you can see here. Can you see here bottom 26.67? That is the forecast for the next month. Similarly, next three is average is 26, which is the forecast for the next month, and so on. Is it clear? Then what we will do is, so this is obviously the SMA forecast, simple moving average forecast. So we take the error term. So error is nothing but your actual sales minus the predicted sales. Okay, now we don't have this data, so this row becomes irrelevant. Now, what we will do is we will take the square error. The square error is error to the power of 2. And take the average of the errors. So if you take the square error is about 142.96. Now look at the moving average. It is not really smooth. See, the data itself is very volatile. It's not consistent, right? So moving average hasn't really smoothened it too much. So let's see what the exponential moving average does. So we again go to data and data analysis. And this time we will do the exponential smoothing. And the input range will again be the sales data. Labels are there. Considering an alpha of 2, we are 0.2, we are taking damping factor is 0.8. And the output range maybe we can keep here. Actually, we can probably do it even, see in this case, we can do it a little ahead also, because this is exponential smoothing. It doesn't have anything to do with 3 months or anything like that. So maybe we can put the first cell itself. Yes. ठीक है. So now the error in case of exponential smoothing. Now you compare the graph. This was simple moving average, and this is exponential moving average. So simple moving average is better than the actual forecast, actual sales, but still it's not smooth, right? So if you go to exponential smoothing, you will see that the forecast is very, very smooth. Can you see that here on the graph? And let's look at the error terms. So error terms here is basically again actual minus the predicted. And squared errors will be this to the power of 2. Now, if you take the square errors and now take the averages of the errors and square errors, can you see the reduction in the square error terms, residual terms? It was 143 million in 143 units in simple moving average, but it has considerably come down in the exponential moving average. The square errors have reduced, right? So the residuals have come down, and you can see the graph also. So the forecast, I mean, the sales, actual sales has been very volatile, but the forecasted trend time series forecast based on simple moving average is shade better than the actual, but exponential smoothing has completely smoothed out your forecast. Smoother means made it more consistent and reduce your crests and troughs. So this is the advantage of exponential smoothing over simple moving average time series forecasts. Okay.